Oak is durable, attractive, and resilient to weathering effects. Aside its extensive application in both light and heavy modern construction works, it also holds an important place in architectural restoration works. Operational use and regulatory requirements sometimes demand enhancing the fire properties of wood, and for that matter, oak. Intumescent coatings are a form of fire protection for wood. They are thinly applied, but at the exposure to heat, they swell up to 200 times their initial applied thicknesses to form a protective covering that essentially shields the substrate from the ravages of fire. So, for example, an intumescent coated timber structure is less likely to collapse in a fire because the coating will swell up to prevent the fire from getting first-hand access to the underlying timber substrate. So why intumescent coating? Because they are efficient, relatively cheaper, and a less intrusive way of providing fire protection for timber. Transparent intumescent coatings, as against opaque types, possess the important quality of maintaining and showcasing the natural grain of wood, an attribute which is valuable in the field of architectural heritage preservation, where oak is predominantly used. The American Coating Association predicts that as construction spending increases, there will be a commensurate demand for intumescent coatings. On the other hand, patenting approval and the commercialization regime of intumescent coatings has been brought under scrutiny because guaranteed performance under varied heating conditions remain unaccounted for, more so when the complex mechanism of intumescence is still not clearly understood. Taking into consideration all that has been said so far, the study intends to experimentally investigate the fire protective capacity of a selected commercial intumescent coating that has been applied on oak by using what is called the cone calorimeter, which is a very effective device in this regard. The findings of this study were interesting. To give a quick summary, the intumescent coating failed to swell under heat application, contrary to what was advertised by the manufacturer. It however managed to minimally mitigate the ravaging effects of the fire on the oak substrate that caused an increment in smoke production, which is not very good as smoke inhalation is the number one cause of death in a fire. Findings of this study will consolidate extant data to guide fire engineers to make informed decisions in specifying products for fire protection of oak. It will serve as a reference point for manufacturers to improve their products and authorities to review the approval framework of intumescent coatings if need be